Today, we will be studying shear diagrams. As you know, a simple beam is a beam that is supported in the extremes. If I have this beam here in red color, and I do have, usually in the extremes, I do have a reaction. For example, this is reaction 1. It can be also drawn as a simple arrow, and this is reaction 2. This beam will be supporting some loads. And in our particular case, we have one unique load here, but we can have also a distributed load. This distributed load, as you know, is distributed along a specific distance, for example, a distance of 2. And if this load is, for example, 10 pounds per feet, and the distance here is 2 feet, well, this will be 20 pounds. We have another load here, for example, of 10 pounds. Both together are 30 pounds total load. Reaction 1 and reaction 2 will have a total value of 30 pounds. In order to calculate the reaction 1 and reaction 2, we need to eliminate one of them. And that's why usually we calculate the moment here to eliminate R1, and we'll be able to calculate how much is R2, etc., etc. Well, after we have our beam ready with our two reactions, this is an object that is not moving in the space, and the total value of vertical forces, the sum of vertical forces, will be equal to 0. Also, the sum of moments in any place will be equal to 0. However, that doesn't mean that the moment is 0 in each part of the beam. We can cut the beam, and with cut the beam, we can look how much is the moment in the right and how much is the moment in the left. The sum of moments at the right and at the left of these particular points is 0, but that doesn't mean that the moment in that particular point is 0. It's the sum of moment that is 0. Well, that beam will have what is called a maximum moment. Also, a beam have a maximum shear. Well, today we'll be calculating what is the maximum shear. As you know, a beam will usually fail because of bending moment, but we need to check if the shear is adequate or not. And that is what we'll be doing today. We will be calculating the maximum shear of that particular beam. Calculating shear is not something difficult. It's exactly like doing a balance in a bank. For example, in order to do the calculations, the first thing that we will do is to just draw some lines. We will draw a line. I like to do it like dot lines at the end of that beam and at the other end of the beam. And we will leave space for to do two diagrams. Today we will do only one, but always leave space for two diagrams. Well, I will make a line, and this line will be the level 0. That will be the place where the shear, and usually I can write an S in this diagram, the shear will be equal to 0. The first step is that we need to understand that always at the end of the beam and at the start of the beam, the shear will be equal to 0. I will start my diagram in 0 and finish in 0. If the diagram do not finish in 0, it's because something is wrong. Thereafter, I will start drawing my diagram. And the diagram will be as follows. I start in 0, and I see that just before the beam start, there is nothing, is 0, always 0. But immediately when the beam start, we have a force of 25 kilonewtons. That is like receiving a positive balance because it's a force going up of 25 newtons. What I will do is that I will draw a line, and I will calculate the scale and imagine that this distance is 25 units, and I will write there 25. This is the first shear that I have. A shear that is cutting, we have the beam, there is a force that is pushing off, is cutting, and is 25. It's like you receive $25. You receive because it's going up. It's a positive balance. Well, you will write here plus 25. Thereafter, nothing happens. During the first 2 units, nothing happens, and I will go straight. I mean, my balance in the bank will be $25. Well, I will go straight, and that means that the balance is the same, just the moment in the point 2 where there is a force negative of 30 pounds going down. Well, I will imagine that those 30 pounds is like money again, and it will be receiving a balance of 35 pounds. Sorry, $30. Well, I will go down 30 pounds or $30 in my balance, and I used to have 25, and now I have -5. In the stream is 0. In the moment just after 0 is 25 because we receive 25, and in 2 from 25 I have -30 here. Well, the balance of the shear is -5. Look, in all the next period of this diagram, all the rest here, nothing happens. Well, my balance will be the same. I don't need to make any change. Finally, at 10, we receive 5 units going up. It's 5 kilonewtons in this case, can be pounds, can be dollars, whatever, but from -5, whatever is the unit, I will arrive to 0. And my diagram closes in 0. That is all. We have a shear diagram. And what we can know here is that the maximum shear is 25 because it's the biggest number, not because 25 is positive. If it was -25, it will be also the maximum shear. Well, in few words, if this beam break some way because of shear, break over there, I'm sorry, let me go back, break over here in this area between 0 and 2, break somewhere there, is because we have a maximum shear of 25. Thereafter, it's difficult that the beam will break because of shear, because the shear is only -5. And that's it. We already have the shear diagram. Next week, we will learn how to do the bending diagram. Let's go and look the next example. In the next example is very similar, but we have 2 forces. Well, I will do my diagrams, and in order to do that, I will make some dot lines. Let me use a smaller one, red color. I will make some dot lines at the end of the beam, at the start of the beam. Sorry, this is the end, the start. We can tell that it's this in the left. 1, 2 is the end. And I will look where thing happens, and look, I looked at something happens here because we have a force of 20. That means my diagrams will change in this point. And here we have 10, where we need to do also some dot lines. And those are the points where I will have change. I know that changes will happen there. Well, again, this is very simple. It's like having to conciliate a checkbook. To just check my balance, I start always in 0, always in 0. And I go to the first element, the summatory of moments is 0 in the place where it's 0. We call this place 0 because we can tell that this is 1, this is 2, this is 3, this is 4, this is 5, 6, etc. until 12. 12, that is the end of the beam. I start in 0, and immediately after 0, I have a force pushing up that is a reaction of 21.696. 667, sorry. Well, I go up. and you draw this very well drawn with rules, and you imagine what is this value, you will leave some space. Putting the numbers together, you know that nothing can be more than 30 because you have 20 plus 10. Well, you keep a space like 30, like here, and you arrive to 21, and you know that this is the first line of my diagram. What happened next? Nothing happens. Look, in all this period, nothing happens. Well, you go straight. But when you arrive to the point 2, something happens. There is a force of 20 going down. That is like going to the bank. I have a balance of 21.67, and after I receive a bill of 20, how much I got? At 10, I go only 1,667. Well, I go from 21.67, I go 20 units down, because it's what happens here, 20, and I arrive to 1.667. What happens later on? Nothing happens. There is nothing happens that happens during the 4 units. Well, I go straight, and finally we receive again a -4 going down. My all balance here in green was 1.667 positive. When I receive 10 negative, I will tell myself this is 1.667 minus 10, 8.33. Well, I need to go down 8.33. I mean, I go down 10, and because I have 1.67, I arrive to 1.8333. Nothing happens here. I go straight. And obviously, the last number needs to be the same, 833, in order to close in 0. If I don't close in 0, it's because I did a mistake. Let's try to do a mistake. Look, I am in 0, and I go down 21.97, and nothing happens. Mistake, this is pushing up. I am supposed to go up. Nothing happens, and I go down 20. If you go up 20, you're doing a mistake, you need to go down 20. And another mistake, you write here 20, you will not write 20. 20 is this brown line, that the value, the length of this line is 20, but you start in 21, therefore you arrive to 1. Nothing happens, and you go down 10, etc., etc. It's like going to a bank. It's not difficult. Let's go to the next one. And we have here something different. Here we have a distributed force. As you know, when you have an exercise like this, the first thing that you will do will be to calculate the reactions. And well, this force of 10 kilonewtons, that is all this force, is a force that is applied during 4 units. From 4 to 8 is 4 units. This length is 4. You multiply 4 by 10 because it's 10 kilonewtons per meter. It can be 10 pounds per meter. You multiply by 4 and you will have 40. In the middle, just in the middle, I'm sorry, let me close this here. Just in the middle of this force that we have applied, here, I will write a vector of 40 because it's 10 multiplied by 4. Well, I do it in a different way, in a different graph to don't get confused. The middle here is 6. Well, in 6, I apply 40, and now I can do the calculations. Well, look what happens. We do our calculations. We arrive to the conclusion that these R1 and R2 are equal. It's 20 because it's a symmetrical element. And let's look what happens with my beam. First, I always start in 0. Immediately, I have a force of 20. I go up 20. Nothing happens. and I continues. It's like I cut the beam. If I cut the beam here, this is 20. If I cut the beam here, we still have 20. If I cut the beam here, we still have 20. If I cut the beam here, we still have 20. We don't need to cut the beam so many times. We just go straight. We know that it's 20 until here. But here we have a force of 10 kilonewtons per meter. I mean, you have 10 here in 4. We have 10 more here when we arrive to 5. We had 10 more when we arrive to 7. We have 10 more when we arrive to 8. And we have 10 more when we arrive, well, here is 8, sorry. 4, 5, 6, 7, and we have 4 more when we arrive to 8. That means that I need to go from 20, I need to go 10 down in this distance. I go 10 down and I arrive to 10. I go 10 more and I arrive to 0. I go 10 more and I arrive to minus 10. I go 10 more and I arrive to minus 8. Let's try to do this again mathematically. Let's look here. Summatory of moments in 0 is 0. Just after 0, we have 20. We arrive to 20. What happened in 1? We still have 20. What happened in 2, in 3, in 4? We have 20. We have 20. We have 20. When we arrive to 5, we have 20 minus 10, the first part, the part in red, that is equal to 10. We can write here a number that is 10. What happened in 6? Now we have the red element, but we have another one. We have the yellow also. Each one have 10. 10 plus 10, 20. Well, in 6, we have 20 minus 20 equal to 0. In 30, 20 minus 30 equal minus 10. In 8, 20 minus 40, all this area equal to minus 20. And like this, we calculate every 1 unit, etc., etc., etc. That is too much. And that is the method of the textbook. I don't recommend it. I think that we can do something much easier. And that's what I will show you now. It's the same, but it's easier to calculate. Look, we know that we start always, let me go back, always we start in 0. Always. The shear will start in 0. Again, sorry. And I will start in 0 here. Let me go to the one before, sorry. Is this one, number 2. Well, I will start in 0 here. 0. I have 20 going up, I go 20 up. Nothing happens, I don't need to calculate what happened 1, 2, 3, 4. I know that will be continuous. It will be the same 20. After this element is 40, well, I just calculate what happens in 8. 40 here. That is negative because it's going down. 20 here, positive going up, is minus 20. Minus 40 minus plus 20 is here, look. In 4 was 20. And in 8 is minus 40 plus 20. That is minus 20. This is the point that I need to do, and I just wrote a straight line between them. Because I know that it's going down little by little. If I take, imagine that this is something like a, I don't know, like a bread. You have a sandwich bread and you have many tranches, many. Well, you are in 20 and you go a little bit down, a little bit more down, a little bit more down, more until you arrive to the first place, this one. And this is 10 kilonewtons. Well, you are here in 10. Because from 20 positive, you need to have minus 10 negative. And again, half will be 20 and you are in 0. But why to do that? We know that it's a line that is just having the same proportion. It's an inclined line. Well, we arrive here to minus 20. Nothing happens. I go straight until the next time that I need to do a calculation, that is 12, because we have 20. 20 minus 10, minus 20 plus 20, 0. Nothing happens, I go straight. Ready. This is the idea, and it's much, much easier than cut the beam every fit. Let's go to the next exercise. Here we have a beam, and the beam have one force here that is, let me go back, that is 0.12, it's like a point of 20, and one distributed force during 4 units of 10 kilonewtons. I mean, this is 40. I have 20 plus 40 is 60. I calculated 2 reactions, total 60. I am ready to do the diagram of the moment. When I do the diagram, we need to be clever and we need to tell yourself, let's do calculations only where we need it. Well, what are the points that we need? The points are the following. You will take that beam, you will look at the beam, and you will tell yourself, let me draw lines in the places where thing happens. Well, happens something here at the end of this beam. I think that this drawing needs to be a little bit bigger. Let me change it because it's my SAT. Let me make this, oh my goodness. I need to go out from the presentation, sorry. Let me make a little bit bigger, and now it's okay. And here is good, and this needs to also be bigger, like here. Well, I will just draw a line here where the beam starts, where the beam finishes, and where thing happens. Here we have 20, I draw a line. Here I have the start of 10, I draw a line. Here, the end of 10, I draw a line. And here, where we have 23, that is the last, I draw a line. I have the distance here. Those are the points where there are changes. Those are the only points that I will calculate. And the truth is that you need to calculate 1, 2, 3. The last one will be a confirmation that everything is okay, and here is 0, and here is 0. Well, not so much calculation. Let's make it in the easier way. I start in 0. And in this point, I have 36. I just go up 36 units. I go up 36 units, straight. Nothing happens, I go straight. Therefore came the second calculation. I had 36 point up, I have now 20 point down. I need to go down 20 units. I draw a vector of 20, and 36 minus 20 is 16. And I arrive to 16. Nothing happens in the next 2 units, and I go straight. Next came a distributed force. Because it's a distributed force, I cannot go punctual, like going down. I cannot do that. I need to go little by little. Going little by little means doing something that is an inclined line. That's all. How much I will go down? You can calculate if you want, and you can tell yourself, well, I need to go down 10 plus 10, 20 plus 10, 30 plus 10, 40. This total is 40 because it's 20 kilonewtons by 4. But why to do that? This is 4. You just go 40. From 16 minus 40 is minus 23. This line is 40 is minus 23. I write here minus 23, and I make a straight line between them, and that's it. Next step, nothing happens. Because nothing happens, I go straight. And after I have 23, well, from 23, I need to go minus 23. I arrive to 0. Because here there is nothing, I continue going straight. And my diagram is ready. What is the main result of this diagram? That the maximum shear is 36.67. By the way, if this number was not 23, but was 43, minus 43 or 53, whatever, this is the maximum shear because it's the maximum number. Well, the maximum shear always is the maximum number, no matter if it is positive or is negative. In our case, it's a positive one and it's 36. Well, the shear here is ready, we finish. Let's look at the next one. The next one is exercise 4. The particularity of this exercise is that, as you remember, we have forces in the two sides. And if we calculate the moment in this point, this force will have a different unit than the other force. If this is negative, this is positive. But after this is done, the exercise is very similar to the ones that we did before. Again, we just take this particular beam and make some lines, and I will do now the same because I realize that this is smaller. Let me do the change here. This needs to be a little bit bigger, the same dimension, you see? And this draw need to have the same dimension. But I will make a line. It can be a dot line at the end of the beam. And at the start of the beam, and I will make a line where thing happens. There is one point that is this, because there is 20, and there is another point because we have a reaction that is this one. I make those lines, and I know that I will always start in 0. I will always finish in 0, always start in 0, finish in 0. And I will do the calculations in the points where I have changes. Let's start with the first one. We have 11.67 going up. I go up 11.67. Nothing happens during all this period. I go straight. Next, I have a force of 20 kilonewtons going down. From 11, I go down 20. 11 minus 20 is 8.33. I go down and arrive to minus 8.33. Nothing happens. I continue straight until I arrive to this force that is a reaction that is 18.33. Well, minus 8.33 plus, because it's going up the vector, 18.33 is 10 positive. I arrive to 10 positive. I write 10 here, for example. Or you can write there. I like to write the 10 here. And next, nothing happens here. I go straight. And I have a force of 10 going down. I go down 10 and I arrive to 0. I start in 0, I finish in 0. The maximum shear is 11.667. The second maximum is minus 8.333. Another is another one of plus 10, another of 33. What is telling me that the beam may break here or here, and there is less possibility to break in this place. Remember, shear is like a scissor, will break the beam like that. And this is ready. Let's go to the next one. The next one is 5. The next one you will do the math by yourself, but I will explain you how it is. Again, remember, in this particular exercise, past week, you substitute 20 by a force of 20, you substitute by a force of 20 multiplied by 2, sorry, that's 40. Well, you are supposed to write here 40. You were supposed to write here 50 multiplied by this distance, that is 7, that is 350. You do all the calculations, and those are the reactions. When the reactions are ready, we are able to start calculating our shear and moment diagram. And this class, as you know, we will do only the shear. Again, I start and make a line where the beam start and where the beam finish. Again, I will make this a little bit bigger. And I also will make some lines. Those are lines that will help me to do my diagram. Well, those are dot lines. I have one here where we have 20, one where 50 start, one where 20 start, one where 20 finish, one when 50 finish, that by coincidence is the same of this one, and one with the finish, the beam finish. Those are the places where I need to do my calculations. Well, and I start with my diagram as follows. I start in 0, and there is a force of 130. Well, I need to go up 130. I go straight 130, and I arrive to 134.17. That is this number. Nothing happens, I go straight. We have a force of 20, well, 130 positive minus 20 negative is 110. We go down until 110. Nothing happens, I go straight. We have the first part of a distributed load. This is the first part. Here we have 50 pounds. Multiplied by the distance, that is 1 is 50. Well, I need to go down 50. From 110, I arrive to 60. I arrive to 60, I put this point, and after I put the 2 points together, this is the first line. Second, I have here 20 plus 50 is 70. Okay, I have 20 plus 70, but I have 70 in this area and 70 in the next one because we have 2 units, is 140. Well, I need to go from 60, 140 down. 140 minus 60 is 79. I have a straight line of 79. Next, this one is 50 only. We don't have 20 or 50, only 50 during a distance of 4. That means this area, let me change color. This area has a weight of 200. Well, from 79 negative, I need to go 200 down. That is to 79 something negative. I arrive here and I make a straight line. After we have 289 going down, going up, I go up 79 plus 10, I arrive to 10. Nothing happens, I go straight, and after I have 10 negative plus 10 positive is 0, and I finish in 0. In few words, when you have an arrow point up, you will have a balance that is positive and you go up. When you have an arrow pointing down, 20, you go 20 units down. When you have a distributed force going down, you look how much is this weight, that is 50 multiplied by 1, and you go 50 multiplied by 1. Let me put it in red, sorry. That is 110 minus 50, 60, and you go down this distance. Here you have more weight because you have the 150 multiplied by 2. You see, 50 multiplied by 2, the 2 red arrows, and after you have in yellow 20 multiplied by 2. That is 40. Plus 100, that is 50 multiplied by 2 is 140. Well, you need to go down 140. From 60, 140, you arrive to 79, and this is the line. You see, this line is a little bit more inclined than this line. This line is like this other is like that, because it's going down more. And after the next one has a different, let me clean everything, have a different inclination. Look, this is like this is a little bit more straight. If you exaggerate the lines, you will be able to understand what I am speaking about. Let me clean everything. Look, the first one is something like this. Let me do it with this tool, it's easier. This is the inclination of the first one. This is the inclination of the second one. It's like a little bit more inclined. See? Etc., etc., etc. Let me clean everything and go to the next exercise. The next exercise is an exercise where we have one distributed load of 40 pounds, that is this. Another one, sorry, one punctual, like point of 40, another punctual of 20, our two reactions, obviously. And finally, one distributed force of 200 kilonewtons per meter. 200 multiplied by 4. This is 800. For the calculations, you put 800 here. You forget about this one, and you calculate how much is R1 and R2. After that is done, you start doing your diagram. And the diagram is quite easier. We do the same that we did before. We just have a dot line where the beam start, where the beam end, where we have 40 and the start of 200, where we have the end of the 200 weight, where we have the other reactions. And those are the parts where things will happen. Even in the shear diagram, look, this is a straight line that became a curve, etc., etc. Well, let's start doing this. As always, I start our being in 0. I start in 0. We have 427, we go 427 units. You need to drop this on scale in your papers. Nothing happens, I go straight. I don't need to do any calculation. Next, I have 40 going down from 427, I arrive to 387. And I go down 20 units. This is this vector. After we have a distributed force, starting in the same point. How is the distributed force? 200 per every meter. I mean, from 87, I need to go 200 down, plus 200 down, plus 200 down, plus 200 down. How much is that? 800. Well, from 387 minus 800 is 412. And that is the line that I draw. You don't need to draw many lines, only one line. Because this is constant, you just look the value before, that is the value that you had originally, 387 plus 0, plus the value of 800, that is all this guy, that is the next value, minus 412. It's inclined because go little by little. Remember, it's like you have pieces of bread, one piece of bread, another piece of bread, another piece of bread. Every time you go in the same way, with the same inclination. Well, nothing happens in this area. I go straight, nothing happens in this area. There is 432. Well, I go 432 up. And because I have 412, I arrive to 20. Nothing happens, I go straight. There is a force of 20 and it closes in 0. If it doesn't close in 0, guys, you have a mistake somewhere in this diagram. Okay, let's look. The next one is the same. And I will do this a little bit faster because you already got it. Look. Here there is nothing. I start always in 0. Nothing happens. I continue in 0. We have 153 going up. I will go up 153. 153. Oh, but there is 40 going down. I need to go down. Why to draw that in that way? Let's do it. 153 minus 40 is 113.333. Well, from 0, I go straight, and I go 113.333 up. In the next part, yellow color, nothing happens. I go straight. In the next one, I have 100 units plus 100 units because it's 2 and it's 100 kilonewtons per meter. That means this is 200. I have 133 positive, 200 pushing down negative. That is 86. 200 minus 133, 113.333 is minus 86.667. 3 decimals to make sure that there are no mistakes, and I go straight as an inclined line to 86. You see, distributed forces make inclined lines in the shear diagrams and curves, by the way, in the moment diagram that will not be working with. And straight lines is when nothing happens, it will be an inclined line in the shear. But we're not working with shear, sorry, with moment. Well, we forgot about this one and we continues. We finish here in minus 86, nothing happens, I go straight. We have a sort of 20, 86 plus 20 is 16. I go down, nothing happens here, I continues, and by coincidence, my number here, 1667, need to be the same than the reaction in order to finish in 0. What is the maximum shear here? Again, it's a positive 1 and it's 133. 1 minus 106 is a small number, cannot be the maximum shear. But again, remember, the shear can be negative. Let's do the last one. And the last one, we have a distributed force and 2 punctual forces. We already calculate the shear that is, sorry, the R1 that is 39 and R2 that is 61. Well, in order to do this project, we just do the following. We start always in 0. We have 39, we go up 39. Nothing happens, we go straight. We have a force. I changed the color just for your information. You don't need to do it. 30, from 39, I go 30 down. Look, this 30 is the same as this vector. This vector is 30 long. 39 minus 30 is 9. Nothing happens here during all this period. Well, I go straight. We have a force of 10 kilonewtons, can be 10 feet, sorry, 10 pounds per feet. It's the same. During 2 feet, 10 multiplied by 2, 20. Well, we need to go down 20. From 9, we go down 20. And if we do go down 20, we arrive to minus 11. Well, the line is inclined. Why the line is inclined? Because the force is going down little by little, and it's a distributed force that makes an inclined line. Next, nothing happens. In all this area, nothing happens. I go straight. We have 50 going down. I need to draw a vector of 50 units. And you choose the units in your scalimeter. Depends the dimension of your paper. You go 50 down. Well, this is 50. But we have before 11, therefore this number is 61. 50 plus 61, because both are negative. Minus 11, minus 50. Nothing happens in the last part. Here, nothing happens. Therefore, we go straight. Finally, we arrived to 61. Coincidence, it's the same number. Perfect. That means we didn't do any mistake and we close it 0. And that is all. You have other exercises that you can practice in the book. And I hope you will be able to practice a lot to understand the shear. That is very important because look, we are doing a calculation of beams, and in the calculation of beams, if you don't know how to calculate the reactions, that is the first step, you have the rest grown. Well, you calculate R1, you calculate R2, you make sure that R1 and R2 are equal to these 3 forces together, 30, 10 multiplied by 2, 20 plus 50, and it's correct. Then you calculate the shear. You need to understand how to calculate the shear because look, this area of the shear is this number. And this area is the number 1, the area 1 plus the area 2. Well, you need to have the shear correct to have the moment correct. And in the test number 4, you will need to calculate moments and tell me what is the maximum moment. If you don't know how to calculate the reaction and calculate the shear, you will be unable to calculate the moment. Well, it's important that you start doing exercises and understand how to do everything well. And this concludes this presentation.